Section 7.2, Math 110, Operation and Matrix. Here, we want to discuss how would you take a couple of matrix, add and subtract, multiply too. So what you have in each matrix, you have entries here, and you understand that when you call the matrix Aij, I is the number of is location of the row, and this is J is for the column. For instance, the A11 means your entry is in the first row and the first column. Like A33 means you're on the third row and the third column. Like what does A31 means? Remember, the first number is always represent row and the second one column. This one means this entry is on the third row, 1, 2, 3, and the first column. So here, like in this example, I have A11, which is 2. A12 means first row and the second column is -1. A21 means you're on the second row and the first column. Okay. All right, so now here, how would you add two matrices? You just take this one, the first entry of this, and add the first entry of that. Second to the second. See, this is this entry is A1, 2. This is also A1, 2. So you're adding these together. So like here, 0 plus 0, 1 plus 0, and so on. You could also take the matrix and multiply. Like, what does 3A means if you have the A? It means you could take each entry and multiply by 3. See, you bring the 3 and multiply by each entry. What is negative B means? Means -1 times these. So if you ask you to calculate 3A minus B, 3A minus B, you take the matrix of A and multiply by 3. Okay. And then add minus B to it. Now, when you add these two, you come up with this. And here it shows you everything that you could actually do with the matrix. Like here you have, there are 4 of them, right? This is negative. You add all these. 1, -1 is 0, 0, 2. 2 and -1 and 1 cancel, 2 and -3, -1. Okay, so you have everything in. See, because this is the first entry, this is the first entry, this is the first entry, so you could add all the first entry together. Now, how do we solve the equations 3x plus a equal to b? Okay, so normally, if you want to solve this equation for x, you understand that you have to take a to the other side, divide, and you come up with this. X is what? 1/3 of b minus a. So basically, what you need to do, if you already have matrixing of a and b, you need to subtract it, and then the outcome multiplied by 1/3. That would be your x. So x is 1/3 of b minus a. B minus a. That's how I calculate the x value. Now here is product multiplication of to the matrix, okay? So the way it works is you start from this one. You take the first row and multiply the first column. I'll show you here. The first one, which is -1, 3, you want to take that and multiply by the first column. First row, first column. First row, first column. So it would be what? This times that plus this times this. So it would be -1 times -3 plus 3 times -4, which is -9. That's why you have that here. So this row, first you take the first row, multiply the first column and then the second column. Then you take the second row, multiply the first column and the second, and so on. And the same thing, you take the first row multiplied by the second column, first row multiplied by the second column, then you start from there. The second row multiplied by this, second row multiplied. One thing is when you want to do the multiplications, like this one, you want to make sure that the column of the second, the number of column here and the number of the rows on this, these two always match. Okay. Like why is this one is not working? Because you have 2 and you have 3. These two numbers must always match. When you do it, say you take this and multiply by this, you take this and then you don't come up with the right answers. You can't even do it because 2 times 3, it doesn't match because you need to have at least 3, right? So again, you want to make sure that J of this and I of that one, or number of column on the first matrix and number of row on the second matrix are equal. Another thing is they call it identity matrix. What is identity matrix? Identity matrix is a kind of matrix that diagonal here, all the number and the diagonals are 1 and the rest are all 0. I want to show you, like if you take a number, let's just, you take a number and multiply by 1, does 1 change anything? No. Same thing. If you take a matrix and multiply by 1 or by identity matrix, that doesn't change your matrix. Or if you take 1 and multiply by matrix, that doesn't change anything. So they call it identity matrix. Again, identity matrix has, in the diagonal, you have all number 1, and then below and above this line, every entry must be 0. And where do we use that for the next questions? Like here, how do you find a to power of 2? A to power of 2 basically means take the a and multiply by itself. This one, I want to show you how to solve the linear equations and use Gauss-Jordanian eliminations. What it is, when you have, like here, you have 3 equations and 3 variables, right? First you list all your coefficients here. And then since you're dealing with 3 variables, x1, x2, x3, you write that. And what you have on the other side, you write. Our goal is, and then you take this x1, x2, x3 out, and you find adjoining. Adjoining these two matrices means you have to write it like this. You take these columns and the first matrix, you put it together. Our goal is to change this to identity matrix. When you do to identity matrix, then numbers you have on these sides are your x1, x2, x3. Okay, so again, this method means you take your matrix and change this part to identity matrix by just playing with all these numbers. I kind of show the calculation here for you. See, our goal is that in this matrix, change it to something like this. This part is important because this is identity matrix. What you have on this column are the numbers that you find it. So this is what we need to eventually have it when we play with this. Like what I did first, we all might use a different ways to do it, but we should all come with this part at the end. Like here, first I say, why don't we take the second one, the second row, which we call it R2, multiply this by -2, and then add it to the first one, that gives me the R3. So this is R3, okay, and R1. See, like here, how, you take these numbers here, -2 R1. Like if I take this one and multiply by -2 and add to this 2, make this 0, right? So that's what we did here. And then, so far I have 2 0 here, 1 1. So what I need now is change this to 0, change this to 1, change all these to 0. I take R2 and multiply by -7 plus R3. See, I have more 0 here, 1 1. Now I need to change this to 1, this 0 0 0, and so on. So if you follow this, and it goes to the second page, I finally got to the point that this is my identity matrix. So in that case, this is your x1, x2, and x3. To find x1, x2, x3, you need to change the matrix to identity matrix. This is examples that, they are saying that one of the application of the matrix, in fact, is 2 softball teams submit equipment. They want to purchase equipment, pay for all the equipment. They need 12 bats and 15 bats for men's, 45 balls for women, 38 balls for men's, and all this. If you want to just do the regular calculations, to find how much it costs is this. Look, 12 times 80 plus 45, we need like here, 45 balls, and each ball is $4. So you could do the calculation, you come with these two numbers. This is a hand calculation. Let's say if you don't want to use the matrix, right? But if you want to use the matrix to come up with those two numbers, that's how to do it. So you have all these numbers as one of your matrix. The cost would be the second matrix. The cost is 84 and 90. When you multiply these two, this is what you get. So this is the application of the matrix to find the cost of equipment for us. And on the homework, here is an example. I show you how to use the calculator if you want to. This is an example. Let's say you have these two matrices and you want to multiply. This is how to use the calculator. And I think I might have it one more here. Yeah, this is another one. If you want to multiply two matrices, if you want to multiply these two matrices using the calculator, again, you want to make sure that, see, these two numbers are always match. What is this on the first one? Number of column. And then this one, number of rows. So number of a column of this must match number of row of the second one in order to do your calculations. And that's the result. Okay.